Oh, we started.
Oh, hello.
Hello. Hello, Dmitry. How was Christmas?
That was good. Yeah, quiet. What
That's
about
always
you?
really useful. So today, we've been doing a lot of refactoring. Refactoring, haven't we, really? And I thought it would be interesting to try and write some Kotlin from scratch, really scratch. And the thing I plumped for was a CSV parser or something like it. Something to take sort of text representations of data and parse them into lines and columns or rows of data or something. We already know what CSV does. And really, the thing I wanted to do was do it in Kotlin and then compare it at some point to common CSV, because I really like common CSV. It's very clever. But I wanted to see how Kotlin would change the way we implemented this sort of thing, or maybe the way that the interface turned out.
You mean the library from Apache, right?
Yes, yeah, Apache Common CSV, which is excellent. And actually, if you have to parse CSV files or anything like it, use that rather than this. Because this doesn't exist yet. But this is a start. So I thought we might do TDD, which means you need a test, and we call this table reader, maybe. Maybe create a table reader test.
Or tests.
Table reader test. I like tests. Yeah. That's depressingly empty.
But that's
yeah. Yeah, something. Let's prove that we can run the test, shall we? This is JUnit 5, for better or for worse.
So it fails.
But that's good. Oh, create breakpoint. I haven't seen that before. Do you notice that? Anyway, new thing, new toy. Okay, so what we're going to try and do is we're going to try. So we're going to try and build the interface from scratch from the test and get IntelliJ to do the right thing for us.
Okay.
So we've got to think what the input to a CSV type reader or maybe tab separated type reader would be. And the first thing that comes to mind, to me at least, is it's a list of strings, because we've got a string for every row. So I would start with, say, let's create a val, call it input, and let's make that an empty list of string. We could make it to do, but then our test would just fail straight away, and which is nasty. That's good. Yeah, and then
should we call it something else? Or
yeah, let's call it test. I don't like seeing my own name in print,
Yeah, I know.
It's like hearing your own voice. I don't like to make a fuss. So what do we want the output to be? And that's a sort of key question, right? And the thing that I came up with was list of map of string to string.
Okay.
And the reason I came up with that is that, well, we could sort of sketch what a file looks like, I suppose.
But you mean this, right?
Yeah.
Actually,
because it's, I don't know. I mean, so I guess the other thing we could do, we could say, well, we could write an acceptance test for this thing and say, if we started with these things, what would we get? Should we try that?
Okay.
Maybe that would sort of inform our interface.
Yeah. What do you want me to type?
Well, I don't know. Let's write. Let's create something called acceptance test, shall we?
I'll create it here then, if you don't mind.
Yeah.
Just for simplicity. Tests.
Yeah. I've seen people recently calling them shoulds, like table reader should.
Oh.
So then the test reads table reader should something. Oh, that's quite sweet. Anyway, let's create a test. And I don't know what read. I never know what call tests until I think my head is always either one step ahead or behind. Shall we create a table that looks looks like the thing. So we'll create a here document thing, whatever it is.
So you want me to create a table?
Yeah, let's look at let's create the text.
Oh, you mean this? Basically,
Yeah.
you want
like
to draw string?
Oh yeah, look at that. I don't think we need the pipe, do we?
Okay. I was going to do that.
Well, trimming will do fine, I think.
Okay.
But your mileage may vary.
Okay.
So should we put in a header row? So we'll have something like column 0, column 1, column 2, or something with commas saying.
Column.
That's challenging. I think it's a U.
Oh, sorry.
And a O.
One more?
Yeah. Rule of 3. And this would be sort of data 0, maybe data 0, 0, 0 or something. I don't know what. Yeah, put any odd numbers, any odd things you think in there.
You want this kind of
something like that. Yeah, maybe item or I don't know about you. I struggle between data that's easy to interpret and data that's fun. And this is
item.
Oh, I like item. Yeah.
Oh, it's more like cell, really. If it's a table, then cell.
Cell, if you like.
Yeah, I think that's more consistent with terminology we're using.
So ignoring embedded commas and quoting and that sort of thing, that's a sort of typical CSV file.
Call it CSV or CSV file?
Whatever. It's
not a file.
Yeah, it's content, isn't it, really? And so what we'd like to be able to do is parse that. So we'd like to be able to pass that to something. And then we'd like to be able to take those things and probably map them to some sort of data class, right?
Mm-hmm.
So normally what happens is we've got CSV and then we've got some data and we want a list of 2 things coming out of this. So in the end, if we were to define a little data class somewhere here with 3 things in it, let's say, yeah. What should we put? Should we call them value 1, value 2, and value 3 or something? I don't know what, any old.
Sorry, am I defining data class?
Yes, you are.
Okay. What should I call it?
I don't know what, my data.
And it will have what, header and value kind of thing.
I know it'll just have values, right? So it's going to be one of these for each of the 2 rows.
Oh, right. So this is a row, basically.
Well, so it's got. This is the thing we want to get out.
Right. So there will be 2 instances of my data, and it will have.
Yes, that's right.
3 things in it.
Yes.
Is that first, second, third?
Yeah.
And we want this as ultimate output.
Yes. So what we want our result to be is a list of my data, cell 0, da da da. Yeah.
Right. So something like that, and that's going to be the first one.
Beautiful.
Something like that. And there will be another one with those like ones instead. That's our output. Expected.
Yes. So that's what we're aiming for. And so we want to take a sort of our parser, whatever it is, table reader should support going from that that top thing to that bottom thing, right?
Mm-hmm.
Because sometimes we want to do other things with CSV, but that's almost always what we want to do. We have a class that represents a row, and we want to get out an instance of that for every row from the header.
Yeah, that makes sense. Maybe sometimes you will want to have your custom conversion because it might not be a string, it might be an int. Right?
Yep. So let's do that. So let's make that an int then, and let's make that, and then let's make cell 0 just 1 and 2, or 0 and 1.
0, 1. Oh. Okay.
Yeah. So that would also sort of inform how we think we might want to do this. And the way that I think of this is that we would provide a mapping between something and my data. right?
Yeah, yeah.
And so what we want out is something we can map over, which is a list, and what we're putting in is a list. So I would say that, so if we were to write a function here, or not write a function, but write an invocation, if you like, that we would say, let's take the CSV, split it into lines, because that's an easy thing to think about. So in fact, if you would say CSV, if you, yeah, is there split lines or something in Kotlin?
Splits.
It's interesting that that's harder than you think, isn't it? It's split on
new line. That's I think.
Yeah, it's split on new line.
That's going to be lines.
Yeah, so this is our lines. Let's call that. Let's put that into a variable, shall we? And then we're going to call some function like read table
on each line, like map, and then foo on it, which is a line. That's what you meant, right?
Well, no. What I'm saying is that we want our that's going to be inside the function we're going to call, maybe, but that we want to take our lines. So in the same way as we were kind of messing with interface down there before, we're going to say let's pretend there's a function called read table of the lines. Yeah. Now, what we'd like to be able to do is take the output of that thing and map over it.
Right, I see. Then we do map, and
yes,
we do foo, which converts a line. That's going to be. Well, maybe let's do this.
So what makes sense in there? So what I'm saying is what makes sense to me in there is, yes, something like that, right? And the easiest thing to put in there, it to my data, would be a map.
Yeah, that's what we have in this.
Yes. So that's the reason for me going for this, is that if I wanted sort of when I look at the use case of this, so let's it's easier now to do this, in fact, in our table reader tests. Now we know where we're going. I think we do. I'm not sure any of the audience does, but so let's do the same thing. I'm just wondering. Let's comment that out for now. So we've still got test, and let's go down here and say. So down to the bottom, 29. Let's go to 30. Let's say we've got some output, read table on the input. And it would be nice to assert that was the output, but IntelliJ's, JUnit asserts aren't very clever. So I think we're going to assign the output of read table.
Sorry, you want to assign?
Yeah, let's take, instead of that empty list, let's tell you what I'm going to do. 29, alt enter on the output in 29, and specify the type. That's the one. Yes, and now get rid of the empty list bit and put the read table in point to the empty list.
Oops, sorry.
Join lines 29 and 30.
All right.
Getting rid of empty list.
Oh, I see. Yeah. I get
now I think if you alt enter on that, IntelliJ will knows the function signature, right?
Right, that's clever.
Should
I move it out? Just like
move it out, yeah.
So it's going to be lines.
I think that's lines, yes.
Maybe it's here as well.
Yeah. Now that should actually then allow 21 to compile, I think. Well, it gets closer because it's a thing we can map over.
It compiles.
So let's uncomment 21 so we can see where this is going.
Oh, I see what you meant now. Right. Oh,
and now it in there is a map, right?
Yes.
You can do that, or let's just do it in place here. Let's just say, oh, that's okay.
Helpful.
No, it's fine. Except that IntelliJ, yes, we got way too much time.
Right?
Yeah, way too generic. And so in here we can say, call the constructor of my data, for example. with so that one is the where are you going? You put it down so we can see it. It's almost like, you do this for a living. So what have we got here? This, we can index on this at this point.
Right, I see. So you're saying this, and then we take the second.
So that's we want that to be the name of the column, I think. So that was in quotes column 1, because that's.
Well, yeah. Column 0, right? That's
yes, column 0.
To int.
Yeah.
Or now.
Let's not worry about the error handling for now, maybe.
And this is going to be that. But.
And when I say let's not worry about the error handling, it's going to force us to. So we could do this.get, I think.
Oh, interesting. Are we doing bands?
Yeah, so that.
Okay. Oh, well.
Oh, that's nice of it.
Yeah.
But let's not do that. We don't really care.
I just don't like yellow things. That's all I was trying to do. Okay, disabled.
And never talk about this again.
Right. Like that.
And so that's and if, for example, we didn't have a header line, then we could have go to the values of the map and get the 0th one, the first one, and the second one, for example. So the nice thing about returning a map here is that we have all the options we have on map.
Mm-hmm. That's assuming that the map is linked hash map, right? So
yes. It needs to be have the same order as the things we put into it. But Kotlin maps are linked hash maps, almost always, unless you go out of your way. So yeah, this is the way I think about reading CSV files. I don't know about you, and I like the map as string to string as a way of thinking about each row.
Yeah, that makes sense to some extent. Yeah.
To some extent.
I just feel like we will have columns in it for each row, and that's it's like a very dynamic representation of an object. It's almost like objects in like Groovy or somewhere.
Yes, but then that is what you've got, because you've got you have an entirely freeform thing, which is just this file full of stuff, right? Which may or may not meet your schema. So you've got to you have to find a way of mapping between that freeform thing and your expectations of that freeform thing.
Yeah.
And that can either be that we've parsed the names of the headers, or it can be that we know which index they're at. And yeah, in the end, error handling may or may not be important, depends on how well you control the output, right?
Mm-hmm. What bothers me right now is that we have no assertions still.
Yeah. So that acceptance test is going to be a long time passing, right? I mean, we can add an assertion to it. In fact, that is assert equals the expected we've already got, right?
Oh, yeah, it's all the other way around. Do you want to show me anything? Yeah, so it's expected first. Expected. And it's that. That's the actual. Why is it complaining? I don't understand. No, it doesn't really complain.
Method contract. Never seen it search for one of those before. Add a method contract. What? Okay, let's not do that.
I was also thinking, should we move this maybe above? So it's like CSV converted to lines, and then our expected.
Yes.
This format is a bit.
Now it's arguable whether our CSV parser should take something that is already split into lines, or whether it should split into lines itself. Mm-hmm. I think the CSV standard allows you to put new lines into quoted fields.
Yeah.
In which case, if we really have CSV files, we might want to take the whole set rather than the things already split.
Yeah, but to be fair, this function doesn't claim to be a parser. I think it says read tables.
Yeah, I'm very careful with naming. Shall we skip the acceptance test then?
Yeah. Okay.
Which
Should we even run it or not?
Well, you said,
running it.
yeah. If it's okay, it's done now.
Okay,
Everything
good.
fails. So let's. Is it skip?
Disable.
Disable. Of course.
The unit file disabled.
Okay, and then fold it away so we don't have to look at it again.
Right.
So we'll come back to that. Maybe we'll finish that today. And this one, though, we can get to we need an assertion here, I guess. And if we have no lines, we have no lines, right? So I guess
that's expected. Yes.
No, that's actual.
Okay. I'll call it.
Yeah, I prefer result myself, but you know.
Result, okay.
But we're about to inline it anyway, right?
So what we want result. That's I don't know. We expected first. I don't like that, to be honest. But I would say this is actual. Named arguments at least, and that's expected. I get it.
That's it. Yeah, I don't think you do that because it's a Java API.
And what we want is a list of maps.
Well, it's going to be an empty list, right? It doesn't really.
Yeah.
Given that we put nothing in, we're going to get nothing out. So hopefully our first test
needs all of that, I think.
Yeah, it's irritating, isn't it?
But still unhappy.
It's a Java function, so you can't do that. You can't do the actual expected.
Right, thank you. It has to be the other way around. That's going to fail again.
Yes, but we can make it pass.
Pushing.
We can make it pass by returning an empty list. So let's fake that. Okay. Wow. So we have a passing test, and we have no reason to empty list. So I don't know what this is. Empty list returns empty list or something.
It returns empty list.
Yeah. Let's start swimming to go on.
Yeah. It's like, well, what I was thinking returns empty table, because if we read in table, I would expect table on the output if it says read table from.
So that's interesting, isn't it? Like whether you have a thing in your thing, whether we have a name for the thing that we're returning, because we could type alias that thing and call list of map of string to string table, for example, or we could create a class, or we can just leave it as it is. And our choice here is to leave it as it is, and to try and stay with functions and types that already exist for as long as we can. But in the Java world, we went the other way around. In the Java world, we'd have to introduce types really quickly because we'd have nowhere to put things, and we'd like to, I think it's a way that Kotlin feels different, that we seem to stay with existing types a lot longer. Is that your experience?
Yeah. I don't mind. It's also such a small example right now. So.
Shall we create another example?
Yep.
And we're going to not worry about field names for now. We're going to have a table basically without a header, because we're so let's if we call read table on a list of field 0 and field 1, or item 0 and item 1, something like that. But that wasn't the name of the test. That's what I want you to do.
Okay. Call read table on an empty on a list.
Yeah, so this is going to be a list of, and we have one line, and it's going to say something like item 0, item 1.
Right. Item 0, item 1, item 2. Or is it?
2 will do. I can't be bothered with 3. Like it. Yeah. So the question is, if we don't have a header row, what should our map keys be?
Right. So if this is a result,
Yeah.
we don't need this thing really here anymore. Yeah, and then we want to assert what that is. And I'm guessing it will be a list of 2 maps this time. Yes.
No, it should be listed one map because we've only got one row.
Oh yeah.
And
empty to item 0. Is that what we want?
it could be. I mean, the question
I
is,
don't know.
what should it be?
Yeah, that's a good question.
So it's going to be another one, which is something to item. But so that actually go where you were going, right? Which is to say, we don't know what it is yet. Put in the empty string, right? So we know that the data that we've got is going to be the value of the map. The items in the map is going to be the value of the data at that row and column. But we can't put in blank because that will be a map in the end with only one item in it, because it's not a multi-map, right? There will only be and so we've got to come up with something. And the easiest thing to come up with, I think, is probably the string representation of the index.
So 0, 1.
Yeah. Okay. And why? The answer is that's all we've got, right? We decided the type is the type of the key is a string. And we don't know anything about that string except we could put in something entirely random. We could put in the value of item 0 and value of item 1. So in other words, it could be item 1 to item 0 to item 0 and item 1 to item 1, but that's totally useless. Whereas this would give us the ability to parse even without a header row.
Yeah, it makes sense, but you could also interpret it in a different way. That's the whole modeling of map of string to string is not the best fit for all cases.
Yeah, I mean, it's never going to be the best fit for all cases. I guess the question is it going to do us, right? Let's.
Yeah, but I'm capable to go with
that. So, what's the quickest way to get this to pass?
Let me run it first. And should you give it a better name?
Yeah, I think it's something like one line of input with default field names or something.
One line with default headers.
Well, you see, it's not headers. It's because we haven't got a header, I guess. But so I would say field names, but yeah, that'll do. And so I also have trouble with naming tests until it's almost all done, and then at that point, I feel I'm able to name the tests, and then once you start naming the tests and you find the regularity in the naming of the tests, then then you're able to see the cases you missed as well. So it's nice. So keyboard monkey, make that pass as quickly as you can.
Easier task, right?
Yeah. I mean, so let's just hard code it, right?
Okay. What are we hard coding though? Just
so we know the difference between the cases is that the lines is empty. Right. So if we were to say if the lines is empty,
do this.
Yeah.
Return that. Okay. Right.
Okay. And now there's a thing. There's a thing I learned recently, which is that we need somewhere to put some code, and there's a relationship here that we are. This lines is empty. Is where am I going with this? This lines is empty is telling us that what we have here is a map. In other words, when we had one thing come in, when we had nothing coming in, we have nothing going out. When we have one line going in, we have one line going out. So I don't know any good way of doing this, but basically, if you just say, if this is really return lines map on something that passes a line.
So 5 bits.
Yeah, absolutely. I think maybe parse line, but it's just to keep it in sync with my thinking. Yeah. And let's create that function. And that can be that map that we passed in, or didn't pass in, but you have hard coded at the top, hard coded on 56 at the moment.
Oh, you mean that?
Yes.
It's not a list though; it's just a map.
No.
And then we should be able to just do this.
Yes. So in other words, instead of we're sort of looking at the structure of the data coming in, structure of the data going out, and saying that that's a that's a map rather than an if statement.
Yeah.
The if was just pretending to be, and so now we've got somewhere to build this map, and let's split the map. So at the moment we've got 2 items in the map. Let's split the map into keys and values and zip them together to make the map.
There will be keys, which is a list of.
Absolutely. Yeah. So what we're trying to do is we're trying to gradually replace the data that we've got.
Again, keys, zip values.
To map. And that should pass our test.
Oh, nice.
And now keys, we can see how to do that.
I see what you mean. Well, you mean do something like that?
Yeah, absolutely.
Still work.
And that one is a bit cheeky hard-coded, right? I think that's values size -1 or in other words, we want as many of those as we have values, but we don't know what those are yet.
Yeah, we haven't split the line, right? I see what you mean. It doesn't even matter.
If we did that way around, yes, absolutely.
Right. But we could go for indices then.
Perfect.
That should work. Yeah, it does. Nice.
And now what we have to do is say, how do we get from item 0, item 1 to quote item 0, quote that thing, yeah. And that is split on comma.
Right. So you're saying that split, maybe even like that.
Yeah, there might be that. Try that. So I would. That works personally. Actually, yeah. Let's humor me and make it a string for no good reason other than it might surprise me otherwise. It's rather odd. Split is rather odd because that is a list. Those are in sets of delimiters. Yes. So that would allow us to split on quotes as well, but it'll go away.
Oh, it's easy.
Okay. What's next?
More tests.
More tests. Yeah.
Test.
Do we want more functionality, or are we? So I kind of have spidey senses around line split, which is why I wanted to keep it as a quote, as it happens. I've been bitten here before around split doing odd things. So can we try sending in an empty list and see what we get? Sorry, a list of an empty string.
Okay. One empty line.
Yes.
Just empty line, I suppose. Implies that there is just one. And so saying that's the input is that. And
yes,
I don't know what we get back.
I think you should get an empty map, right?
Yeah, makes sense. Oh, yeah,
and you're going to have to tell it. irritatingly.
Okay.
And I'd be interested to see. Yeah.
All right. So it's
So I don't understand split from that perspective. What it does is it returns an empty, a one item array with an empty string in it if you pass it an empty string.
Yeah.
But let's fix that somehow. We can either say, is the input empty, in which case we just want to return, or we can say, what did we get when we split? Your choice, really.
I didn't understand the first one. I was thinking doing something like let if size equals 1 and something. That was my thinking.
Yes, so we can either say that this is caused by having an empty string as we go in which case you can say values equals if line is empty array, otherwise line split. Or we can say we have some other values.
I think I like this. So you're saying if I like the first one, then if line is empty, then we return empty list.
So I would leave it where. So I would say not return. Not return an empty list, but the result of that expression is an empty list.
By return I meant just
yeah.
So that should work now. Okay.
That's shall we? It doesn't feel like that belongs in parseline. Should we make a function out of the expression of 64? Yeah, we'll call it split fields or something.
Expression.
Yes, do that. And while we're there, let's pull that pull the thing we're splitting on as a parameter, because we do want to see what it is we're splitting on. We just don't want to be worried about the somewhat dubious behavior of okay, so now that's still passing, I guess. Did you run tests?
Yeah.
I was distracted. Okay, so we've done, we have shown an empty table. We've shown a table with one thing. We've shown a table with one thing that's empty.
Empty table, one thing empty.
So we should show that it works with 2 lines, right? Table with 2 items in it. Well, 2 rows in it.
I'll call it table with 2 lines. And like you mentioned, we should just revisit all tests after we've done, right?
Yeah.
Just revisit them all. List of and another line.
Yeah. Now we've got this problem of.
I'm happy to do what we did in acceptance tests. Just add this kind of.
Yeah.
It gets a bit confusing. 0001.
It does.
Binary code.
So yeah, this is these should be 2 items in our list now. Thank goodness for trailing commas these days.
So that's what we want, roughly.
I see the trailing comma is fine now.
Okay.
I know you couldn't help yourself, but.
Oh, wait a second. It worked.
It worked. It's quite clever, isn't it? So it worked because we wrote the map early. Right?
Yeah.
Had we, and I quite like that, because in the old days we would have written a for loop at some point, or we wouldn't have written a for loop. We would have left the if there, and then we would have written a for loop. It would have come. We would have had work to do. But because we saw the map, we saw the map being. We saw that if test being a hidden map. We've got a thing that just kind of works. So we've seen some structure, which is good. Okay, so that looks like a place to sort of check in, have a cup of coffee, so on. I think you read table there. Yeah, you really want to make that single expression, don't you?
Oh yeah. I'll keep it as public. There were other things, I think. Like we could look at the tests and make names more consistent.
We could. I'd be inclined to just inline them, to be honest with you. There's a nice sort of structure in it.
Inline all these.
Yeah.
Yeah, that's what I meant. Just revisit all the tests and make sure, like, we were not in lines here, but we were in the next test.
Yes.
That was a bit annoying, and maybe we should just, if I used named parameters, then they should be everywhere, like all over the place. But that's good. That's result. Yeah. Then you're saying even inline the result as well.
I think so, because the structure's there. In fact, if you then, yeah.
Is that gonna work? I kind of liked this separate lines there.
Yep, I do too.
And then the same here. Oh, no, that's not.
Yeah, IntelliJ
Doesn't
sometimes
align it properly.
doesn't. Yeah, you had one job.
So true. Okay, hopefully. Nice. Even kept formatting almost. Oh.
And the nice thing about that is you kind of see the you can see the structure, can't you, in the structure of the tests. Okay, so read table with header.
Yes. So it's going to be similar to this, but with header.
Yeah, we'll have one line with a header.
Oh, maybe I'll add it after this then. So
controversial. You're going to be scrolling up and down a lot more if you do.
Right. Okay. Let me do this. With header. Then we have a list of.
So I think we'll add in a row that's H0, H, comma, H1 for header 0, header 1.
Okay. Yes.
Oh,
should we call it column, because that's what we had above?
You can call it column. It's longer, but you know, I know
I
how
like
you like
consistency. With header.
And so, what do we expect out of this? We expect it to be taking the names out of our column. Yeah.
And that's not going to work.
That's not going to work.
Yeah.
So, so now we have a question of what should our how should we know that we have a column? Sorry, a header.
Yeah.
And we could call it something different. Well, we could call it something different. We could pass in a flag, right? We could pass in a Boolean for has header. There's a whole bunch of different ways that we could do this. Yeah, not there yet though. So I don't like the flags personally. I would say let's create ourselves a read table with header. But I'm going to be a bit cheeky, and I'm going to say that this should take the header line as a separate thing. For no good reason other than it makes this shorter at the moment, but it'll cause us problems later. But this is the way I did it the first time round, and I think it's useful to see where it takes us. So actually, then our read that should 88, I guess, should be our read table with header. And a header line should be the first one of those. And as an interface, I think I prefer passing in the header line because it's easy to do. But actually, later on, that'll prove to be a silly decision, I think. Okay, so
we want basically.
That's an interface which is good. So where to now, Dmitry?
Maybe
So-
start using this somewhere.
So we can do one or two things, right? We can either hard code it the way we did before, right? So we could write this write this hard code, write this with no reference to the previous read table, right? And then just trying to find the commonality between them. Or we can take the functionality we've got and try and make room for the new functionality.
Right. So that should be private.
Yes, probably. And by make room, I mean that we kind of want to make this thing, we want the functionality we've got working at the moment working, but we can see where to add the functionality we've got.
Right.
And the mistake I always make now is to do that now where we've got a failing test. But let's not make that mistake. Let's comment out the test that we've got or skip it, because otherwise we know what our interface is going to look like now. But it's horrible to have the tests failing as we do a refactor and have to work out that it's okay, it's failing because it's the it's the one that we don't expect to pass.
Right, so I skipped it now.
Excellent. So now, where is our where is the information about using headers at the moment? Where is the information about headers? Yeah, there.
Yeah. We should probably rename this to headers if we have values, and that's like header.
Yes. Now, what is this? So, what is the strategy here for creating a header?
That's the strategy.
So I would say that the strategy is it's toString, right?
Yeah. I see what you mean.
Yeah.
So once we have,
and then we're going to apply that strategy to every to the slots that we've got, effectively. Yeah. So my thinking here is that we've got a thing that I'm going to call, for want of a better word, header provider.
As a parameter.
Well, I don't do that quite yet, because we can do it in here, right? So let's say we've got this thing which is going to provide headers for us, and what does that know? It's given an integer, right? So all it can be given is the thing we know, the index from the values.
So that's what you want, like,
yeah. And it's going to give us a string.
Right.
Yeah. So what's the type of? Yeah, let's put that in there and make that work without the colons, I think. Yeah.
Okay.
So does that continue to pass? Excellent. Let's give it a type on 107. Yeah, so that is the type we think it is, and that, if you like, is the only information we've got here, right? So, and that actually is then just integer color toString, right? That lambda.
Oh, you mean?
So I think you can say replace lambda with function. Can you try it? Yeah, top one.
Oh, yeah, of course. I didn't understand.
Yeah. And then you can do the thing you were going to do, which is pull out a parameter of it.
Right. Nice.
So that's good. And then
I'm not sure, why is it int to string and not string to string?
Why is it int to string?
Well, yeah, or maybe nothing. I don't know, like, because headers are not necessarily integers.
No, but at the point where we're getting them on 107, that's all we know. Right? All we know is we parsed a line into parts, and we know the number of that part. That's the only thing we have.
Right. Okay.
Okay. So we have separate read table with header, don't we? What are we doing here? So that's made room for it here. What I think we're going to try and do is we're going to try and say that this read table with header calls the other read table. Hold on. Before we do, the 99, let's pull the int to string out of a parameter to that thing as well. Yeah, that baby.
That's going to work. Ooh.
Yeah, good on IntelliJ.
Beautiful.
So yeah, and that's been there all the time, hasn't it? So that was our header provider, I think. No, it's not a header line, it's a header provider. It's a thing that, yeah. Does that continue to pass? It does. I think though we've had to change our test to make that work though.
Yes, yeah, it did. All of
so
that.
Should we undo that and see whether we can do that providing the defaults our tests haven't changed?
So we want this as a default.
Yeah.
Should I put them on new lines?
I think if you undo it, you can get there.
I'm doing that.
Undo to there, and then say make that parameter and introduce default value. Yeah.
Yes. I normally would even do it manually because it's not that hard. But okay.
But it's handy. It's nice if you've got, like, with all those tests, every one of those tests is going to need editing.
If we add in default parameter, then we're not changing our tests at all.
Yes.
That's why it's local modification. That's why I would even do it manually, because it's just one line. It doesn't affect the rest of the code.
Oh, I see. Instead of the refactoring.
Yeah, because I know like refactorings are not going to help me a lot.
Never give up faith, Dmitry. Refactoring.
Yeah, well, eventually, when yeah, but now, yeah. But yeah, that's the thing we wanted, so it should still work. It did work.
Okay, excellent. So now, just to sort of recap, we have we've introduced a strategy, the header provider, to our read table, but we defaulted it to the thing that we were doing before. But we pulled that strategy out of the bottom of the code, if you like, and surfaced it all the way to the top, but given a default. And now our read table with header, we want to call our previous read table, but giving it a header provider that is derived in some way from the header line.
And then we want some header provider, but
yes,
something.
Yeah, and I think we can kind of pretend that we know what that is if we say it's yeah. Well, let's punt it. Let's call it header provider for header line, right? Let's pretend there's a function.
Oh, okay.
No, I'm saying pretend we're invoking a function.
Oh, here.
Yes, not there, but outside the lambda. So no lambda. We'll say there's a header provider equals. Yes. Yeah. Excellent. Right. So, because you like your names, header provider for header line.
Like that.
Like that. Yes, absolutely. So that will give us a place to create a thing, and it's going to be an odd one though, because it's going to be a function that returns a function. And your mission is to implement that.
So split, and then access. Well, we need to return a lambda, right?
Yes.
So that's easy. This is going to be index, and it returns a string, so that should compile.
Yeah.
Now we need to implement, which is going to be. We can do it right here, I think, if we do split header line on whatever comma, then we can do index here, and that's it. What do you think?
I think that's perfectly reasonable. I mean, I think we might want to do split fields rather, because we're going to have the same problem. But
Oh yeah, thank you. That works. Well, we don't have a failing test, but okay.
We don't know, but yeah, sometimes there are things that we don't test, we just get right.
We could also optimize this by doing this outside of the Lambda.
I think you should, because otherwise it will be called every time we need a. Yeah.
Then do that. Okay. But to let.
Okay. So now the question is, so again, what we've done is we have not changed any. Well, we've kept everything that was currently working, but we've provided this get out of the header provider. Get out. It's this strategy, I guess. So let's go and see whether that makes our test pass. We've got what we. Yep, it's fine.
Oh, with the new one, yeah.
Yeah, we have a disabled one.
Yeah, of course. Yay. Correct.
So that's quite sweet, I think. Anything we'd like to tidy up while we're there?
Test names, maybe.
Maybe test names. So, I mean, so we probably want to add a test for 2 lines with header, for example.
Right.
And sort of interesting questions about
Yeah, that's actually one line.
This is where our lack of naming consistency comes back to bite us.
That then.
Yeah. No, wrong ones. Those are the columns. Columns stay the same.
Yes. And then we will have 2 lines. Yeah. This is getting a bit confusing. I mean, just the whole formatting is less interesting now. So that looks okay. Yeah. Yeah, it did work. So it all works.
So let's go and look at our API.
You mean that?
Yes. So we've got 2 functions. One takes a header line, the other doesn't. We might want to split on things other than the delimiter that's hard coded at the moment. We'll come back to that in a minute. One of the nice things about this, though, is so what do we do when we want to specify the names of the parameters, names of the columns, but they're not in the file? So at the moment, we've got if they're not in the file, if they're not in that list of lines, then we give them that 0 and 1 quotes. But now we've got a header provider to read table. We could our clients can use that. So how about a test that shows that we can specify the header names?
Sounds good.
And this is sort of that dual show that it works, and these are example tests for our customers, right? Our clients. Header names, should we say? Column names. We call it header and column in places, but yeah. So this will become read table. So we're going to end up calling. So actually, let's say I like keeping those names all the same, right? So if we just do read table without header, as it were, yeah, that one. Get rid of the header line, right? So how do we make that pass?
By specifying header provider.
Yeah.
Which will do something.
Yes. So what would be if we were if we wanted to use this, what would be a nice interface for specifying column names?
Just a list, I guess.
A list would do it. Yes, or a map. So I mean, one of the two. Either a map. So my thinking was a map of int to string.
Right. Yeah.
But your thinking is a list. We can do either, I guess.
List it has indices, right? So it
does have indices.
If you want.
Yeah. So let's try that. Let's pull that out at the top somewhere. Let's say what our header provider is going to look. So let's put a val headers, I guess, there somewhere. Yeah.
The list map would.
Well, let's try your listing. Yeah, column 0 and column 1.
And we want to convert it into this type of header provider.
So I think, though, that is probably just get. I think,
yeah.
In other words, you should be able to say on 1 to 8.
I was thinking along these lines to header provider. That's what I had in mind.
Yeah.
Then we create this extension and it.
Okay. Yeah.
Do something. Oh, generic. That's a string, and that's going to be that type instead of any. We get that back, and then we return to this string. I know it's a string.
Yes, that. Yeah. Okay. But now, yes. So yes, you can do that, but that is literally. Not passing it because we haven't passed it in, have we?
Oh yeah. Yeah. Good. Yeah, that works.
But at this point, I mean, I think you can just inline to header provider, right? In other words, that is literally list of column 0, column 1, get.
Yeah.
That was spectacular.
Refactoring didn't quite work, but because it doesn't know types. My only intention was that if it's a client-facing code, you don't want to think about how to do that. You just write a list and then say, make it a header provider.
I think that's so. What you're saying is that yes, map of int to string or list of string should have extension functions that allow you to create an header provider.
Yeah, we could even overload our read table, really. Just create another read table which takes a list. So nobody needs to think about extension functions. Just there is another overloaded read table.
So that's interesting because I mean, I would try and keep away from those overrides. And do at the very least what you were suggesting, or maybe at the very most what you were suggesting, which is adding in things that allow people to convert from one type to another, because there will be a combinatorial explosion of read tables. There will be one that takes lists, and there will be one that takes a sequence, and there'll be one that takes a reader, and there'll be one that takes a string. And then there'll be one that takes a string with the new lines in it that requires a map, and one that takes a string with new lines in it requires we can't provide all those things, but what we can do is we can give you a toolkit of things to bolt together. So yeah, I like where you went with that, which is the stage where you were before, right? Which is where you had a function. If you undo that one, I guess.
Yeah.
And that's a string to header provider. this it surely is just that lambda is on line 132. Can we alt enter on that lambda? It feels like inside it maybe then. It feels like that really should know that it is a function reference. Anyway, so that is this : get, I think, isn't it?
That should be.
Yeah.
Yes, yeah. So the both, if you think about it, so many just to get these gets.
Yeah. So your thinking is that we can make that a public function.
Yeah.
And then our API is then we've got read table with header, and if you want a header provider that's not going to just give you an integer index, the string of an integer index, then you do that. I like that. So we've got 3 functions in our API.
Yeah.
Shall we shall we see whether we can change the delimiter?
Yeah.
Same way. That's the other thing I wanted to have before lunch.
Yeah.
And so at the moment everything is based on a comma, and we haven't specified that in the test. It's all good. And helpfully at the moment everything goes through one function. So because everything goes through the one function, we know that if we can change that thing and not break anything, then we are quite safe. When there's more than one entry point, that's the reason of having just one entry point, really.
So you just want to extract this, basically.
Yes. So let's extract that. Hold on there. Ha ha ha. Good question. The question is, do we want to abstract the thing that we split on, or do we want to abstract the splitting?
I see. So should we extract parse line or whatever split fields into another function which would pass in, or comma? Yeah.
Yeah. Because if we just extract the character, then all we can ever do is parameterize this thing.
Yeah. Or we want to extract this whole thing, basically, like what I selected, right, as a function which operates on a line.
Yes. So what we're going to do, I think, is we're going to say that the act of parsing a line is string to list a string.
Yeah.
So the thing that we want to pull out is not the comma character, but the parser, the splitter. Let's call it splitter, maybe.
It's a function which does string to list of strings, and it's like default implementation is that.
Right? Yes, we can do that.
And then we can actually call it on line extension function. Oh no, let's not. It's just.
So this is another place where we could have done that less manually, but we might also have ended up with that issue with the k function one.
Yeah, but you see what I meant. It's just so easy with the default value.
Yes.
So we put parameters default value.
Yeah. Okay, so that's our parse line. Where's that called? There. So there's parse line is private, and we are calling it only one place, or header provider. Surely we. Oh no. Okay. So there's no point in having it defaulted. Let's put it into. Let's put it into there.
That should probably be line. And that becomes, at least my feeling, when I have two nested lambdas, I try to put them on separate lines. It's not a hard rule, but I do.
Now, I think we're also using the split fields inside header provider or to header provider. No, hold on. Yeah, no, inside header provider aren't we?
Yeah.
So let's pull the same stunt there. Because we're going to want that strategy, whatever that thing is, wants to apply to a header the same as it wants to apply to.
I'm now putting all the arguments, all the operations on new lines, because otherwise it's getting too long for the screen.
Yeah.
And that makes me feel that we should make them all new lines. But
yes,
that's all
more and more I'm doing that in my Kotlin.
Yeah, but it all looks kind of very verbose now with all new lines. Anyway, so we put in this in there. Oh, it complains about that.
And then you need to use it on 152.
152. Oh, thank you.
Okay, so now we have that duplication of line to line split fields, comma.
You mean this in two places, right?
Yes. So let's make a thing out of that.
Right. So
let's call that. Well, we can either make a function out of it, or we can make a value out of it. My preference is going to be for a value because you'll see in a minute.
Okay.
So can we extract a top level value in IntelliJ from that?
I tried. It says no. I did like extract fields. Oh, I should say continue.
Okay. So it just doesn't know the type. Yeah.
Once again, didn't work. Really?
Yeah. Give it. I think that's split on comma. Excellent. Actually, so it did at least pull both of them out. And now both read table and read table with header could be parameterized by that thing. In other words, we could make that a parameter.
Right. So within this, and it can have this as a default. So
it can have that default. Yes.
Split on comma. That should just work. And we could make this a public value, right? It will be part of the API.
Yes. And then you need to pass splitter in rather than splitter on comma. So, yeah.
That's an important thing to do.
Okay. And so now we could show that you can split on tab, for example. So we could take one of our tests.
Which one?
I don't know, a simple one. Maybe a table with one line. One line with header. How about that one?
Oh, with header.
Because that will show that we've made both of them work. Yeah.
What do we have? That's right.
Yeah. Run it, check it fails.
Yeah.
And then let's go and make ourselves a split on tab.
Great. Oh, told it back.
That's interesting.
Yeah. actual with tab. So it didn't split on it.
Did we not pass the, if you look in 157, no. 166, we haven't passed the splitter onto the read table above.
Oh, I see. Thank you. That was tricky. That's why that's why I should use refactorings and not. It's like, oh, it's default. It's gonna work. Yeah, thank you. That was a tricky thing.
And if we were feeling really fly, we could write a function that produced the function that was the splitter.
Can you say it again? Oh, write a function which will create these values.
Yes.
Okay. So what's called splitter, and it takes a delimiter string and it returns whatever that thing. But this is going to be a delimiter. That's what you meant, right?
Yes.
Then we can test it by just doing that.
And that's the reason for having values rather than functions, because it means that you can, and also it's reads a little easier without the function references.
Yeah, it worked.
Beautiful. Shall we just make our acceptance test pass?
Oh, yeah.
I mean, I think we could have done a little while ago. And when I say make it pass, see whether it passes.
Yeah. Oh, no. That's good. Oh. We don't have the header, right?
Right.
Read table with header.
So read table with header takes the header line, so that's lines 0.
Yeah. First.
Yeah. And then that's lines drop 1. And this is fine for a list, but rubbish for streams, and we'll do streams next.
No, that works.
Phew. Quick recap. We have kind of CSV and TSV parsing with or without header rows working in 2 functions, and no new types, which is quite sweet, really. So our entire public interface is what? 2 functions that return lists of standard Kotlin types that returns and take function types for the ways that you can configure it, I suppose. It's quite convenient to use, I think. I like your list string to header provider. That's a nice addition. We could add map of int string to header provider similarly, right? What would that look like?
Map of
int to string.
Will be the same, really.
I was just thinking it should be the same. It's this dot get. I think that's nullable. That's the problem.
Right.
Get value, is it?
Yeah, so that works.
Yeah, or get value.
That's convenient.
If you call it this dot get value, then that throws, and then
it can replace it with just reference.
Then it's that, yes, yeah.
It doesn't do that.
Yeah. So we'd probably want to add a test for that, but it's dubious whether it needs a test. I mean, the nice thing about that interface, I think the header provider one, is that it allows our clients to decide what they want to do if things don't exist. So if you want a header provider that provides a default value if there isn't one at this index, so we could fall back to using integer toString if it's not in the map or it's not in the list, for example. So instead of having to write code to deal with the errors ourselves, we allow our clients to work out how they want their error exceptional behavior to be.
Yeah.
Wow, I think it's lunchtime. How long has this been? It doesn't show anywhere here, does it? Oh yeah, an hour and 20 minutes. Everyone has suffered enough. I think there's another session here if you had the time at some point around a stream interface of this thing, tidying up those tests, and then comparing the interface we ended up with the common CSV one, because actually common CSV has very similar problems to solve that we do, and solves them in fact very, very similar ways, but subtly different ways. And I think there are lessons around how Kotlin and Java are different, and why Kotlin and Java are different in that comparison.
Yeah, sounds good to me.
Thank you, Dmitry. That was fun. I enjoyed that one.
Thank you. Thank you. Are you doing the same thing in your book?
Yes. Although interestingly, I think this one's better. I may have to rewrite an example. I think some of the refactorings here were nicer, which is annoying. Let's finish this. Bye-bye.
Bye.